Hello, welcome to another session on circles. We have been taking up theorems in continuation. I'll be writing the next one here on the screen. It says the perpendicular from the center of a circle to a chord bisects the chord. Let's understand it with a figure. If there is a circle, there has to be a chord. As per the statement given, I have to name them, that I name as P, Q. There has to be a center O. Perpendicular from the center, I'll drop a perpendicular to this chord, which is PQ. This is given as perpendicular. We name this as L. We have to prove that it is bisected. That means we prove PL is equal to LQ. So what is given to us? Given fact is PQ is a chord of the circle with center O. Also it is informed POL is perpendicular to PQ. So what do we have to prove? To prove which is PL is equal to LQ. To do so, I need to join the radius. I'll just draw this to radius. Now continuing with the proof, what can give us PL equals LQ? If we prove the congruency of these two triangles OPL and OQL, so in triangle OPL and OQL, what do we get? We know that OP is equal to OQ. Why? They are the radii. OL is common, and also we know that angle OLP is equal to angle OLQ. They both are 90 degrees. So by RHS congruency, we prove that triangle OPL is congruent to triangle OQL. Now once OPL is congruent to OQL, we can write by CPCT PL is equal to LQ. That's what we were supposed to prove. Let's move on to the proof of converse of this theorem. I'll write down the converse here as a statement. It says the line joining the center of a circle to the midpoint of a chord is perpendicular to the chord. So I will have to also draw the chord. Let's keep the same names that we did for the last one. This is O. Later on I'll have to prove that. Later on we'll prove that this is a perpendicular. So now again I'll join OP and OQ. Similar to this previous one, here also I write what is given. PQ is a chord with center O. It says to the midpoint. See, look at the statement. It says the line joining the center of the circle to the midpoint of the chord. This one, the midpoint of the chord, that means L is the midpoint, that makes PL equals LQ. What do we have to prove? To prove, we write angle OLP is equal to angle OLQ. They are both 90 degrees. Only then OL becomes perpendicular to PQ. Let's take up the proof. Same as we did in the previous one, we take up in triangle OPL and OQL. With the same proofs, we can write OL is common, OP is equal to OQ, the same reason being they are radii. And now it is given PL is equal to LQ, thereby making these two triangles congruent by S. I can write here by SSS criterion. These two triangles are similar, so I write, these two triangles are congruent. Triangle OPL is congruent to triangle OQL. Now what we get by CPCT is angle OLP is equal to angle OLQ. At the same time, they are making 90 degrees. They are making a linear pair. So OLP plus OLQ, that's 180 degree. Now we substitute one with the other. Maybe I substitute OLP with OLQ from this one. So the equation becomes OLQ plus OLQ is equal to 180 degree. So twice of angle OLQ is 180. So angle OLQ is 180 upon 2, that's 90. So each of them becomes 90, thereby making OL perpendicular to PQ. Let's take one application of either of these two theorems. I again take a couple of minutes to write down the question. The radius of a circle is 13 centimeter and the length of one of its chord is 10 centimeter. To find the distance of the chord from the center. Let's draw this figure. This is the circle. There, the length of one of the chords is given to be 10 centimeters. Suppose this is the chord. I name this as A, this being B, and the length of this chord is given to be 10 centimeter. The question is asking us to find the distance from its center. I name this center as O. To find the distance means I have to find the perpendicular distance of O to this side AB. Maybe we can name this as the point of intersection to be M. To get this length, I also need the radius, so I'll be joining OA and OB being the radius. To solve it, we know that the perpendicular from the center of the circle to a chord bisects the chord. So we'll be dropping this OM, which is perpendicular to OB. Here you can write as a construction, write OM perpendicular to AB. Now in triangle AMO, that being a right angle triangle, as because this is a 90 degrees, so we can write in triangle AOM or AMO, OA square is equal to OM square plus AM square. The radius have been given as 13, so this is 13, this is 13 square. We have to find OM, so it is OM square, let it be. And what will be AM? As because we just said that OM is bisecting AB, so AM will be 5, yeah? So it is 5 square. So OM square will be 169 minus 25. OM is then, this I think is giving 144, thereby making OM as 12 centimeter. So hence the distance of the chord from the center is given as 12 centimeter. Hope you followed it. Thank you.